Hello, and thank you for joining us for the second episode of StemZ Perspectives. We hope you enjoyed our previous episode on climate change and coronavirus. If you're new here, welcome. We are a podcast created by the Young Scientist Journal, a student-run organisation.
Today, we'll keep on the theme of contemporary topics by discussing space exploration and the many recent advancements in the field.
We'll be looking at China's Curiosity rover and the UAE's Hope orbiter.
Yes, we'll also be discussing recent discoveries in the dwarf planet Ceres and the new James Webb Telescope.
My name is Max Harvey, and I'll be one of your hosts for this episode. I'm interested in the fields of photochemistry and astrophysics.
I'm also hosting today. My name is Stella, and I'm interested in the fields of AI, astrophysics, astronomy, and aviation.
Great, so to start off, we will give a brief history of space exploration.
The telescope was invented in the 17th century, which allowed for astronomers to look at objects in our solar system and later stars and galaxies much farther away from us.
It wasn't until the mid-20th century that we were able to explore space through unmanned and manned spaceflight. NASA's famous Space Shuttle program officially started in 1981, which is not that long ago.
We've definitely made a lot of progress in the small amount of time we've been doing physical space exploration. It's exciting to think about all the potential things we'll discover in the near future.
Yeah, definitely. And even more countries have joined the space adventure since the mid and late 20th century.
Just last month, on the 19th of July, the United Arab Emirates sent out their Mars orbiter called Hope. This is the first Mars mission by an Arabian country.
With the orbiter, scientists aim to study the Martian atmosphere. It will hopefully arrive on Mars in 7 months. It also aims to inspire young scientists in the Middle East.
Yeah, and more specifically, the Hope probe aims to study how energy moves through the atmosphere and the role of oxygen and hydrogen atoms combined with this energy from the sun in contributing to atmosphere erosion. The satellite is also different as it lets us see a greater part of Mars through a very large elliptical orbit. So this is a really huge achievement for the UAE and international efforts to increase space exploration. Wonderful discoveries are yet to be met.
I think the following years will have a lot in store for us. Just this year, there have been so many discoveries, especially with regards to Mars.
Yeah, the Mars missions have really been in the forefront of space exploration. In fact, 2 weeks ago, the Curiosity rover marked 8 years on Mars, and it's definitely achieved a lot during those 8 years. One major accomplishment is that Curiosity has found evidence of former liquid water on the planet. There is still debate on whether or not Mars currently has liquid water on its surface. However, it is almost certain that it used to have liquid water.
Yes, and in 2013, Curiosity found some conglomerate rocks that pointed towards the existence of a now dried up stream bed.
The news article that announced this discovery says that the rocks show many similarities to those on Earth. For example, the area has alternating pebble rich and sand rich layers, which are typical in stream bed deposits on Earth. That typically means Mars is a close twin to Earth, maybe?
Scientists have also detected many elements and organic compounds that provide possible evidence of Mars's habitability and possibility for microbial life.
So, near the Gale crater, Curiosity's landing site, scientists identified sulfur, nitrogen, hydrogen, oxygen, phosphorus, and carbon. These are the fundamental elements of life, or at least as we know it on Earth.
A question some people may have is, how do scientists detect elements remotely using spacecraft? So specifically on the Curiosity rover, there are these two instruments, the Sample Analysis at Mars instrument and the Chemical and Mineralogy instrument.
The sample analysis one the sample analysis one has a mass spectrometer, a gas chromatograph, and a laser spectrometer as its main components. The mass spectrometer separates the different compounds and elements by mass. The gas chromatograph separates gases into their various constituents. Finally, the laser spectrometer measures the isotope abundances of carbon, hydrogen, and oxygen in the Martian atmosphere.
And all the data gathered in these processes is analysed by scientists on Earth. And then the chemistry and mineralogy instrument uses a technique called X-ray diffraction, which helps determine the structure of the sample.
The science behind the Curiosity rover is really interesting, and we recommend going to NASA's website if you want to learn more about it.
You should definitely check it out. Aside from the elements that were mentioned previously that are necessary for life on our planet, we also know that Mars has boron. A 2016 study discusses the first observation of boron on Mars, and because boron-oxygen compounds known as borates have been found to be necessary in stabilizing ribose in RNA, the researchers believe this is a sign of the habitability of Mars.
There are also some opinions on what this boron implies for the groundwater on Mars. Currently, scientists say that for boron to be able to form in mineral veins in the first place, the groundwater needed to be 0 to 60 degrees Celsius and of a neutral to alkaline pH.
Yeah, another discovery that's really intriguing is the Mars methane mystery. Essentially, scientists have found fluctuating levels of methane gas in the Martian atmosphere, but it is still unknown what exactly causes these fluctuations.
Curiosity doesn't have the instruments for figuring out whether the methane comes from a geological or biological source, so hopefully measurements from other Mars spacecrafts will be able to find out more about this. However, this could be a really interesting discovery, especially if it comes from a biological source. It could bring us one step closer to finding life beyond Earth.
Exactly. However, the newly launched Perseverance rover doesn't have the necessary equipment either, but will definitely still be able to learn a lot more about Mars once it reaches the planet in February 2021.
Definitely.
I think this is an excellent point to go on to our next topic, which is the dwarf planet Ceres.
All right. So, a brief background on Ceres. Ceres is a dwarf planet located in the asteroid belt between Mars and Jupiter, where it is the largest astronomical object.
Even though it's the largest body in the asteroid belt, it's actually quite small. It's 14 times less massive than Pluto, which is smaller than our own moon.
Yeah, and even so, Ceres comprises 25% of the mass of the asteroid belt.
It's an interesting object. What's more interesting is that in terms of structure, Ceres is similar to the terrestrial planets, so Mercury, Venus, Earth, and Mars. Similar to these planets, its interior is layered, although in Ceres these layers aren't as clearly defined.
One thing that sets Ceres apart from those four planets is that it has a low density. Scientists believe that this means it's about 25% ice by mass. And in 2007, NASA sent its Dawn spacecraft into space to learn more about Ceres. Well, actually, Ceres and an asteroid called Vesta.
Yeah, one of the things Ceres is known for is these really bright regions on its surface, which are deposits of sodium carbonate that likely came from a liquid coming up to the surface and evaporating.
Since Dawn spacecraft got a close-up view of Ceres using its data, scientists were able to gather that the liquid itself came from a reservoir of salt-enriched water.
Yes, and currently they think that this water is about 40 kilometers deep.
It's impressive how much information the Dawn spacecraft has been able to supply.
Researchers have actually also been able to determine the approximate age of these bright regions. They're pretty young, astronomically speaking, with some being less than 2 million years old.
Considering Ceres is around the edge of the rest of the solar system, so around 4.5 billion years old, 2 million isn't much in comparison.
Yeah, definitely.
Also, when confirming that the bright regions are young, scientists speculated that these regions might still be geologically active.
Yes, their finding of salt compounds in these areas actually is interconnected with this speculation, because for the salt-enriched water to be located at Ceres' surface, they need to have emerged from beneath the surface relatively recently.
This is because salt-enriched liquids dehydrate quickly on Ceres.
Yeah, exactly. So to sum it all up, Ceres has icy geological activity. When we think of geological activity, we always imagine Earth and volcanoes, but that's not the case for a lot of bodies in our solar system.
Yes, our solar system has a variety of different environments. Every object in the solar system has a different surface, atmospheric, and interior characteristics. With all said, let's move on to the final topic.
Our last topic of today's episode is the soon to be launched James Webb Space Telescope.
This telescope is set to take over and continue upon the Hubble telescope's mission.
The JWS telescope will cover longer wavelengths than Hubble, allowing it to peer further into the past. More specifically, James Webb will cover the wavelengths of the 0.6 to 28 micrometers, which are infrared wavelengths. And so essentially, James Webb will be observing the formation of the first structures in our universe. The electromagnetic radiation from these structures are redshifted, meaning that by the time they reach us, the wavelengths have been stretched.
Yeah, and on another note, James Webb data will be used to conduct research in the epoch of reionization, which happened approximately 150 million to 1 billion years after the Big Bang. As stated in the name, this is when the universe, specifically the hydrogen gas in space, went from being electrically neutral to ionized. So definitely a lot of discoveries will be made during its observation years.
For sure. One exciting prospect is the advancements that will be made in galaxy research. Some key questions that the James Webb Telescope will try to answer are how galaxies form, how they are influenced by mergers, and how they are influenced by their central black holes.
The how galaxies form question is definitely a big one. Scientists are more certain about celestial objects such as stars and how they form and how they evolve. But then when it comes to larger structures, there is still a lot to figure out.
On the opposite end of the astronomical spectrum, so the more small scale astronomical objects, there are exoplanets, and James Webb will also be very useful in researching them. A lot of current research is focused on exoplanetary atmospheres and the question of habitability. For figuring out the elements in an exoplanet's atmosphere, a method astronomers use is called transit spectroscopy. The James Webb observes in the infrared, which is beneficial for that type of research.
There are so many questions and research areas that the James Webb Telescope is equipped to study. It will launch next year, 2021, so hopefully many new things will be discovered soon and we can't wait.
Yes, and once it's launched, it'll orbit what's known as a Lagrange point. These are points where the gravitational forces of the two large bodies cancel out, so a smaller body located at the point will remain at rest relative to these two bodies. And actually, one of the Lagrange points in our solar system, the L2 point, has been used for spacecraft in the past. You may have heard of the Planck spacecraft, which worked on the cosmic microwave background.
The launch and spacecraft details of the James Webb are all fascinating, so it's definitely worth looking into some more.
Yes, NASA has tons of information on their website, both on the James Webb and their other space missions.
I think that brings our discussion today to an end. So, just an overview today, we talked about the future Mars missions such as the Perseverance rover and the UAE Hope orbiter, as well as what the Curiosity rover has found so far in the planet.
Then we turned our conversation to the dwarf planet Ceres, located in the asteroid belt between Mars and Jupiter. It's been very much in the news lately due to the confirmation of salt water underneath its surface.
And finally, we discussed the James Webb Space Telescope set to launch in 2021.
Thank you guys so much for joining us for our second episode.
If you'd like to learn more about the Young Scientist Journal, the organization behind StemZ Perspectives, you can visit ysjournal.com or our social media handles, which will be linked in the description. Again, thanks for listening, and we hope you found today's discussion interesting.
See you next time.